Hi folks, just wanted to give you a brief introduction to the intermolecular forces of different liquids lab. So in this lab, you're going to be setting up a very basic experiment where you're going to need two cups that are identical in size and shape and material. So you want two of the same cup, ideally plastic or paper or better, especially if you're using your digital scale because like a glass mug is probably going to be too heavy for your little scale. Okay, so you need two cups. You need liquids. So the liquids you need are water and tap water or bottled water. Either one is fine. And either rubbing alcohol, isopropanol, or nail polish remover, which is acetone. And you're going to need a measuring device. You can either use your digital scale or you can use your graduated cylinder. So you can either measure the volume change. You can either measure the liquid, the amount of liquid changing by mass or by volume. So I give you some flexibility here. There are some reminders here about how to make sure you're keeping this experiment controlled. That's why we're using two identical cups. We're going to do the same amount of liquid in each one, and you're going to keep them in the same place for the same amount of time, etc. So on this page, you can kind of note what liquid you choose to compare, the isopropanol or the acetone, and whether you're using the mass method or the volume method. So the mass method is on page 2 and the volume method is on page 3. You do not need to do both pages, one or the other. So for the mass method, you're using the digital scale. You're going to basically weigh the cup, and then you'll add your liquid. And the instructions are to add 40 grams of liquid. So you're going to add an additional 40 grams to what the weight of the cup is. You want to measure both though. So you don't want to tear the scale, you don't want to zero it, because you want to be able to subtract the mass of the cup at the end. Okay, so, well, technically you won't need to subtract the mass of the cup, it'll be incorporated in there. Okay, so you will do this for both liquids. You'll put 40 grams of each liquid into the two different cups and you'll let them sit for 2 hours at room temperature. And you'll come back at 2 hours. You'll take a picture. You'll weigh them. You'll get the final weights and you'll take a picture of those final weights. Mainly the picture is just to show me that you did it and that you're not making up your data. So you'll write which liquids you used, what the mass of the empty cup was for each one, what the initial total mass reading was, and then what your final total mass readings were. And then the mass change, the change in the amount of each liquid is just going to be the final minus the initial. And so you'll be able to see which liquid lost more mass. And in the space below here, I have instructions for you to create a labeled drawing. So this is an important learning technique known as modeling, asking you to think about what it is that you saw, both from a macroscopic level, like with your eyes, the water level the liquid level going down in the cups, and what is happening at the microscopic level, so at the molecular level, what is happening to those molecules? They are leaving the liquid and going into the gas phase. So just sketching that in a way where you're labeling what each thing is a really good metacognitive activity and shows me that you understand what was happening in this experiment. The other alternative is to, instead of using 40 grams of liquid, and measuring the mass, is to use 40 milliliters of liquid and measure it using volume, a volume measuring device, so using a graduated cylinder. So measuring 40 milliliters of water, putting it in one cup, and then 40 milliliters of your selected liquid, and putting it in the other cup, leaving them both for 2 hours at room temperature. And then in order to measure the volume at the end, you pour them very carefully back into the graduated cylinder to take the final volume reading. Again, that's helpful if you have paper or plastic cups for this, because you can kind of pinch them to make a pour spout so that you can pour it without spilling back into the graduated cylinder. And then you'll take a picture of those final volume readings to show me that you're not making up your data, that you really did it. And you can put all that data in this table here, organize it here, your initial volume, which should be 40 milliliters for each, and the final volume, which should be somewhat less than 40 milliliters for each. And then you'll calculate the change, final minus initial, and there's a space for you to draw out the what's happening at the macroscopic and microscopic level. So again, you only need to do either page 2 or page 3. So you have an option of whether you want to measure the mass change or the volume change. And then the last page, page 4, is lab questions. So this one kind of just asks you to explain why these different structures, these different substances that were used in this experiment have different boiling points based on their intermolecular forces. And then that's kind of just a general question that you can answer while the experiment is ongoing. And then at the end, you can answer what happened in your experiment. What did you see? Did they track with what you would have predicted based on your answers to part 1? And I do want you to use that CER answer format. So it says, in your experiment, which liquid had the strongest attractive forces? So your claim should be an answer to that question, a complete sentence. The liquid that had the strongest attractive forces was blank. And then the evidence is you citing your experimental data, the mass change or the volume change that you saw. And then your reasoning would be referencing the molecular structure, the intermolecular forces, maybe some stuff that you talked about in question 1. So that would be a complete answer to this question, showing your experimental evidence and supporting it with the knowledge that you have about intermolecular forces. Okay, so have fun.